if we look at the strategies for constructing tests, it's really important when we look at developing tests that we understand that we started with this whole like software can do anything view. And then we narrowed it down to, well, I just want my software to do this. These are the requirements and please do this. When we test a system, we have to understand that users can do anything they want to. Just because the requirement says this, this, and this doesn't mean that the users aren't going to come up with some crazy things to try out in the system. That's what security is all about, particularly security testing, is users finding very inappropriate things to do with the software that break it in ways that are useful to them. That's how hackers break into systems, is not by following the requirements or analyzing the requirements for what the system's supposed to do. It's for figuring out how can I break it in ways that are interesting to me. And certainly I don't care if they're interesting or helpful to you. They're particularly interesting to me if they're not helpful or useful to you. So in testing, it's useful to be aware of this concept called the Pareto principle. So what this is saying is that 80% of the errors in our software is most likely to occur in a common 20% of the modules that I'm going to be testing. So again, maybe my login feature is not going to have very many errors because everybody's written login 100 times. I've actually recycled the code from another application, and it's just not likely to work. So those 5 modules, 2 modules, 1 module, whatever it is, they're not going to have many errors. But this other thing is really, really complicated, really, really new. We don't know a lot about it. That's probably going to have a lot more errors to it. So the bad news is 80% of the testing is going to find very few of the tests cases we're going to have, and the other 20% is going to find a whole bunch of errors that I may or may not know about. But the good news is we can leverage this principle to plan our testing and to predict how our testing is going to come out. So if I can identify the modules that are most likely the problematic one, what I can do is I can focus more testing on those modules. If I can identify that module is going to be problematic, I can probably push it earlier in the test cycle to make sure that the testing gets done early and I have more time to fix bugs inside of there. If I figure out a lot of things are happening in a bad module and I've only tested 50% of the module and I found 100 bugs, I can probably guess that there's going to be another 100 bugs out there. So I really want to prioritize the work the developers are spending in not only fixing the bugs I've identified, but looking for where they're going to be in other places, where else they might be out there, and where other bugs I can proactively fix before I even find them. So this concept is important to look at the test data. It's the measurements and metrics we talked about in some of the early lectures here, where I can not only use the tests as a way of telling me whether my system's ready, I can use the data to tell me where I'm at in my testing cycle, where I can improve my process and how I'm working at as I go. So when we talk about testing a component, at a minimum, we could be talking about a single class. And for a single class, we want to be aware of what's interesting to look at. So I don't necessarily care about simple things like getters and setters, things that are probably going to work, things that are probably going to be fine most of the time. And so I want to focus my testing around all the other features that are going on inside of there. The things that really I'm adding that are more complex and more interesting. Sometimes I can get away with stuff because I just know that, I mean, if I'm going to go sell an item on eBay, I must have logged in at that point. So I know that the basic login feature must work, right? I don't need to test that again. It's an example, not necessarily the best example, but an example of where I can take advantage of that. But most importantly, I need to realize that my tests are going to align to the different flows that users can go through in my system and the different flows in the code as it analyzes data coming in. And so the flows are going to come every time a decision's made, every time a loop happens, every time the code branches in some interesting way. And so this is a flow chart. It could be a high-level flowchart. It could be a line-by-line flowchart in the code. It doesn't matter. But as I look at this, there's most likely a primary scenario that goes here. Our orange arrows. A, there's a decision. That decision leads me to B. Another decision. That decision leads me to F. But it's not the only scenario that's out there. Every single other path or combination of paths I could take. So in this case, 1, 2, 3, 4, 5, 6 different boxes has 5 different scenarios by which you can get through. So those 3 decisions basically expand out the different branches I could go through. And I might need to test part of A, B, C, D, E, and F, and the combinations thereof to ensure that everything works. So a single test of A doesn't give me all the different combinations. A single test of C doesn't give me all the combinations. Even F, there's not just 2 ways to get to F, there's many more than that. So I have to consider all these different paths. And so, as I said, when I'm doing a checkout in a shopping cart, I need to understand in my system, if I added an item from a search, is there a difference between adding an item from a search versus adding an item for browsing, versus adding an item from an email link, versus adding an item from a recommendation or a wish list? If I know they're all the same through analysis, then I only have to test it in one different way. But if there could be differences, like, hey, if I add it from a wish list, maybe I get 5% off. Or if I do it through a search, maybe I need to also log the how often searches, there's analytics that get done for how often a searched item or how long it gets added to a shopping cart and how often does that gets purchased when it's all said and done. So I might need to understand in detail each one of these different flows and what rules and what different requirements might lead into this. And you can't forget about exception flows, things that break. Hey, your credit card's declined. That's not necessarily part of the expected flow. Or things like my server ran out of memory, or I get a divide by 0 error. There's all sorts of exceptions that I have to plan for and account for to make sure that I don't end up with security holes. If I put in a product of $0, or I submit a payment of $0, it causes divide by 0 error and allows me to get root access to the system, in which case I can wipe out my debt entirely. That would be a bad thing, right? So we want to test the failures. We want to test the exceptions as well. Now, all that comes down to understanding inputs. We have to understand the data that's provided to the system. The branches are driven by those input data. And so if I do an analysis of inputs, it can help me lead to which branches are taken and which branches are possible to get to. So I need to consider boundary values when I'm looking at that. So if I'm inputting a number, if that number is supposed to be between 1 and 100, the interesting values is at the boundaries, 1 and 100. Interesting values is right outside the boundaries, 0 and 101, and then whatever values are internally. So that's an approach we can take to understanding. Every time I see a rule, particularly a rule that defines a boundary, I need to consider there's probably 3 test cases I need to do at, above, and below that boundary. And if there's 2 boundaries, then there's 5 test cases because there should be one number in between them in each case. So we need to look at both the flow of the system and the data that goes into the system to be able to appropriately consider test cases. If our system has state, then we have a further wrinkle on everything. So the state's going to show up in source code, but if we don't have the source code, if we're just looking at design, and we know that, okay, so your phone has a safe mode that's going on inside of it. And so in the safe mode, you can make phone calls, but perhaps you can't download new apps. Or there's certain apps that aren't allowed to execute in safe mode. And so that means I have to have a set of test cases which runs in normal mode and a different set of test cases which runs in safe mode. And because things that are allowed in normal mode might not be allowed in safe mode, or things that will work fine in safe mode might not work the right way in normal mode for whatever reason. So that's the idea behind state transitions and understanding state inside of your application. And then loops add a whole new wrinkle to testing because they not only give you 2 paths of code, they give you 2 paths that happen over and over and over again. And then if I have loops within loops, it adds even more complexity because then I can have a exponentially growing number of possible ways these 2 loops are interacting and combining. So for instance, simple loops, I have a loop, a do while loop, and a while loop, or a for loop that's going to happen inside of here. I need to consider which values cause the loop to start, which values cause the loop to end. I need to be able to consider, well, in here, we'll just jump to the next slide. I need to skip the loop is there some way I can make the loop so it never executes? Is there some way I can do one pass alone or two passes or any number less than the maximum? I need to check right below and above that boundary if it's possible. In a for loop, I don't necessarily have to do all that because it's self-contained, it's bounded. That's why for loops are more desirable to use in code. But in a while loop where it's unbounded, and particularly if the index variables are externally driven, particularly if the user has some input to go in, I need to test all different possible values that could be coming into that. And then when I have nested loops, it becomes even crazier because I might have a loop within a loop. And the structure kind of like that means that I need to do all the testing we talked about, starting at the innermost loop and then cycling out to the outside loop. So I keep the outside loop solid and play with the inside loop, and then I can start playing with the outside loop. So again, it's not super important for this class. I'm just kind of presenting some ideas for you to show you how complex the detailed testing can be as I'm going through and trying to figure out the behaviors of different features and different functionality.